Tree crops. We don't just want farmers to grow anyhow tree crops. We normally do budding and grafting. So this is a budding knife which we use in budding. So this one now is African star apple. African star apple. African star apple. So last year during the rainy season we were able to bud some of them. You can come over here. See, this one has been budded and lopped. See the lopping. This one will now be cut, while the budded one will now grow, which is budded. So what is the reason for budding? There's what we call precocity, earliness to flowering. So when it is budded, the plant normally flower very early. So in order to help the farmers, instead of this kind of tree takes a very long time. And we have another one here. This is Avenger gabonensis. Avenger gabonensis, locally called ogbono. It takes a very long time. It takes up to 30 to 40 years before it will produce. So what we normally do when we bud it, it will start producing from 5 to 7 years. So we want to use this one to encourage farmers so that they will plant trees. And if they plant trees, then that will be form of reforestry and agroforestry, so as to bring back the trees, because this place is supposed to be a forest region, but now we call it savanna, forest savanna transitional zone. So if this land begins, if the forest is cleared and it becomes a savanna, then there will be desert encroachment, and only grasses will grow here. And if only grasses grow here, then this perennial problem of Fulani herdsmen attacking farmers will continue to increase. So even to reduce the Fulani herdsmen coming to this side, if farmers learn to plant trees, grasses do not grow on that trees. So it's also a way of diversifying the income. So they will receive produce from these tree crops. This African star apple is very, very, very important. It sells very well. One tree, a farmer can get up to 20,000 naira from one tree. So we intend to bring in other trees, citrus, African pear, avocado pear. Some of them are in the farm. We have a farm. We have a farmer field school where some of these things are growing. So, and we will also have to reach there. This is Ambrose Ali University, Emado Campus, Ekpoma, Edo State, Nigeria. It's situated in latitude 6 and longitude 6. So in 2016 we started this conservation agriculture with 100 level students, where we taught them on no tillage, permanent soil cover, and crop rotation. So we have made a lot of progress. So this year we are continuing with conservation agriculture. So as you can see, we now have a tank which is elevated, and the drip and the irrigation system I showed was what we used here when we started this experiments. So here is a fence. This fence is meant to prevent cattle rearers and the cows from penetrating the place. So if you see the outside here, you see that the plant materials that were cut are still on ground in situ. So when these plant materials decay, they form organic matter and humus. So by next year, we will not need to start looking for manure to come and fertilize here. Now there is also in this multiple engagement of a thing we are talking about, there is also what we call alley farming. Alley farming normally put some tree crops on the alley. So this one here is a gliricidia, the one we use in making fence. But we are not interested in all those gliricidia again. We now want to use pigeon pea. Pigeon pea cannot be eaten by cows, and once it grows, pigeon pea has a very good advantage because it can suppress weeds. It doesn't allow weeds to grow, and it is a biennial. So once it grows, it will produce a crop. Next year again, it will produce crop. This one is advantageous to gliricidia. Gliricidia will grow, but farmers do not benefit from it. So instead of using gliricidia, we are now using the pigeon pea. So this pigeon pea will now grow, suppress the weeds here, so that weeds will not grow along here, and also act as a fence. So we are going to sell this one to farmers, the use of alley cropping, so that farmers can plant this pigeon pea around their farm anytime they have problem with cattle Fulani people. So this is an experimental area for crop science department. We have experiments inside. My own students have planted rosette and soya bean, but from where the experiment started, this other side is just a kind of discard. So we decided to plant maize. See, so the time we planted maize, because of this extreme weather condition, rain just fell in February, and then it just stopped. So while that rain fell in February, we decided to just plant this maize. This maize was not irrigated, but thereafter there was drought until May before rain fell again. But because of the mulching preserves soil moisture. Not only it preserves nutrient, it also preserves soil moisture. Soil moisture is one of the important factors that affect crop production. So if we can use mulch to preserve moisture, then farmers can have good yield. So there is need for permanent soil cover. See what it has done. It has already almost reached harvesting stage. This is just the discard. We'll now go inside. You see the experiment proper. This is the experiment of my project student. We want to see the influence of temperature and photoperiod. Photoperiod is an important factor that influences production of crops in the tropics. We are living 6 degrees north of the equator. So in the equator, sun is always overhead. So, and in this region, forest, savanna, agroecological zone, we really don't have problem with moisture during rainy season. So we have enough water. We don't have problem with solar radiation. So the major problem that affect crop production is temperature and photoperiod, and not much has been done on photoperiod. So this is rosette. This rosette, this is the first planting. This one is the second planting. We are going to have 24 planting, 2 planting every month. So we do not need to always do photoperiod experiments in the lab, where you provide light and then you provide darkness. No. If one crop is planted in February 15, for example, that crop, maybe after a month, we start floral production. If you plant another one in March, it will start its own floral production in April or May. So by varying the planting dates helps to also vary photoperiod during the replanting time. I mean, monitoring the photoperiod in situ on the farm. So monitoring the photoperiod in situ on the farm helps us to know exactly the photoperiod that stimulates the crop to produce flowers. If you see this rosette, in literature, rosette does not produce fruits, flowers and fruit, or especially fruit, until around November. But because this one was planted February 15, this first experiment was planted February 15, you can see that this one was able to produce flower, but they are budding. See, it has just fallen off. So no fruit is produced. It has been producing flowers, but no fruit because of photoperiod. So the essence of having this photoperiod experiment is for us to know when we are going to use irrigation. A crop like rosette does not need irrigation, because if you irrigate it, it will only be vegetative growth without fruits. So there are some other crops like soya bean. So this is soya bean. Farmers normally plant soya bean in July in this region. But this one was planted, this is the first experiment, it was planted 15th of February, and it was irrigated. I removed the drips so that sun will not continue to beat it. Now that rain is falling, this is May. So you can see the production it has produced now. But maybe I'm still studying. Maybe the one that is planted in June is June is the longest. June is the longest day. So the one that is planted in March, we are yet to see how that one will produce fruits. So supposing we have 2 peaks of production for the one that is planted in February, and then production for the one that is planted in July, then we cannot tell farmers to plant soya bean 2 times with irrigation. Okay? So until this photoperiod experiment is done, you will not be able to actually tell farmers when to irrigate and when not to irrigate. For rosette, we will not advise farmers to plant dry season when there is no rain. But for soya bean, we can do a kind of advisory to farmers and tell them, okay, plant dry season soya bean. For very important reason, the soya bean we bought in IITA last year, which we used, and the viability was good. This year, by February, we could not use those seeds again. So viability of soya bean in this region is a problem. So if we can have this dry season farming, then it means we can produce a lot of seeds so that farmers will not have problem with seed failure, seed germination failure. So if we conclude this experiment and we now discover that there are 2 peaks of production, then it will be very good for advisory services to farmers. We can as well tell them rosette. One good thing about rosette is that it's very resistant to pests. So, and since it's resistant to pests and diseases, farmers can, instead of just planting yam and cassava as a routine, farmers can now plant rosé, and they will still make a lot of money from it. So you can see soya bean, the production is very nice. You can see the production. You can see very good. This is the first planting. The second planting too, it has produced. But some of the observation we are seeing now is that the height is reducing and the number of branches. Okay, the number of branches is reducing and the height also is reducing. So when you go to the other side, you see that they are already flowering. This first, second planting. This is even the fourth planting. This third planting, look at this third planting. This third planting, you can see, is flowering without branches at all. So this is the effect of photoperiod. So for 24 to 25 times, we want to plant this thing throughout the year and see the particular photoperiod that is causing soya bean to produce seeds, and the particular photoperiod that does not allow soya bean and other crops to produce seeds. You can see that the farm also is covered. So we want to sell this idea to farmers to cover the land permanently. Covering the land permanently also helps to reduce weeds. You can see that the weed is not growing. Cover it permanently throughout the year. You get your good production. You get your conservation of soil, conservation of nutrients, prevention of weeds, and then you avoid land degradation. Even you avoid soil erosion. Even if there is flooding now as a result of extreme climate condition, you see that if water comes here, it will not be able to carry the nutrients away. So this is what we are trying to sell to farmers through advisory services and students as well. So this is a project in the university campus, Emado campus, which we are trying to sell to students and farmers alike. Thank you very much.